So Sandy said I should probably talk about what the urban forest is, otherwise I might be taken to a guillotine in front of a whole bunch of foresters. So we'll define what the urban forest is and why it's important. I am also a classically trained forest entomologist, studied with Sandy and Ecke, so understand the invasion ecology. So what I really hope to do here is be a bridge between y'all and the urban forest, and then tie that together with the human side. Wrong way. So we've all seen these slides with the ports of entry, but usually what's left out is this urban area factor, right? I hear so many talks, and even today, where it goes from the port of entry and then all of a sudden it's magically in the forest. But actually, first it goes to these urban areas, right? To the tree nurseries, and then to people's gardens, and then spread from there. So that's kind of the focus of where I'm at today. So yeah, I know this is probably the third time you've seen this, but really we're going to be focusing on these urban environments. So the urban environment, right? These are the areas that we live. These are the areas that we sleep at night. These are the areas that we eat food in. And there's some pretty nice houses, and some of these houses have some decent gardens, right? Well, where do we get these? It's from these nurseries. So this is kind of one of these big sources of invasion from so many different guilds of insects, pathogens, viruses, bacteria. We don't want to leave the microbes out for sure, right? So if we think about an area like, you say it, I'm not going to say it. How do you say this?
Košice.
Yeah, Košice. Yeah. I'm not going to attempt that, right? If we look at this urban area, but then we look at its surroundings, we can just imagine that this is an area where maybe plants are moved into nurseries surrounding this urban area and then spread out to the forest. So that's kind of just the framework of what I want you to think about today of where we're going. So I'm just going to say a little bit about the company that I work for you to understand the geography of it. So we have about 192 field offices in North America. We have a research lab in Charlotte, North Carolina, and then we have 5 regional researchers that go around the United States serving our field offices. And then in the UK, we have about 14 offices where I work, the research lab here around Reading. So our jobs are to go out. You give us a call, we come to your house, we look at your trees, and we diagnose on the scene everything that could potentially be wrong. Usually we're looking at trees, right? Almost everything bad about the urban environment is in the soil. That's where most problems start, is in the soil. So we do everything from soil work. We do a lot of your traditional tree pruning, but we do a lot of soil sampling and a lot of soil remediation on the urban landscape. Again, we have a research lab. This is where somebody like me will go out with our sales force. Maybe there's a problem they don't understand. They have a client that say, I would really like an expert opinion. I will go with them to the client's house, diagnose their trees. I do technical training, so how to inject insecticides in the trees. We do a lot of biological control, so when, where to release biological control. And then we diagnose about 14,000 plant samples a year. That's quite a bit, right? We have an expert lab of diagnosticians. So I'm making a call to you. We look at plants every day, and thousands and tens of thousands of plants, and we have a huge geography. Please work with us. We want to be a bridgehead that work between the researchers. And I would argue that we have a lot of information that we can share. So I also look at us as the second line of defense, right? Ecke said this earlier. We have millions of containers. There's no way that Customs, Border Protection, or any country can look at all of those containers. There's multiple levels of people that are actually looking at and touching these plants. I say second line of defense, maybe it's the fourth line of defense. These nurseries are getting them. Then you have landscapers touching these plants and actually putting them in the ground. We're kind of looking at them after they're on the property. But we have arborists that if we train, and this is a really good scenario of where we trained, 2 weeks prior, I had done a training where I was talking about laurel wilt disease. You mentioned laurel wilt disease this morning. So Travis, who is based out of Nashville, Tennessee, went to a military base and looked at a whole bunch of dying sassafras. Sassafras are in the Lauraceae. And then he looked underneath the bark, and there's a whole bunch of stains. So I got a picture. I was on the ferry out of Oregon to New York on my way to Massachusetts, and I got this picture from Travis. And I said, I think that's laurel wilt disease. So he sent it to Andrew Lloyd, our plant pathologist. Sure enough, he plated it up and identified it, and that's what we got. So we really can be some of these second lines of defense. This is a picture I got about 3 weeks ago. Brown tail moth is established in the UK, but this is in somebody's backyard. It's a defoliator as well as can cause some rashes on your arms. So we are out there all the time looking at these plants because people call us and say, hey, there's something weird on my tree. Will you please come look? So we're getting behind the scene in people's backyards where you're probably never going to have access to. So that's my argument there. This is a very recent case. So Nivularia palvinata. So this is, all I can say is a cemetery in London. It's an ongoing thing. And this is a situation where the Forestry Commission informed this garden to cut down some very old established evergreen oaks. Now this is a scale insect. From my point of view, they're very easy to control. We have tools to control these. And so what is the cost of removing established trees on the landscape for a pest? Yes, I mean, is there worry about this spreading and whatnot? Sure, but we can manage this. So it's always this conversation, and I mean, of course, I want to work with governments, but I also want to have that conversation of how do we manage these sort of insects on the landscape and what should be our protocol. So here's my question. How do we manage pests and diseases in the urban forest? I'm going to go into IPM here. That's something that we usually don't do at these meetings, but very quickly, just to think about something. Boxwood, right? We're all familiar with boxes. There's a million problems with this, right? Boxwood leaf miner, boxwood spider mite, box blight, Volucella blight, box dieback. They call this box sucker. I don't know if that's a great term. We'll call this boxwood psyllid. And then, of course, box caterpillar, right? So for one plant, as I'm walking around the urban landscape looking at all the plants, you can imagine that this is only one plant. There's so many other plants that have so many problems and diseases. So I have to know, my job is to know every plant and every insect and disease or cultural problem on all of those plants. So we are expertly trained in these things, and we need to manage them, or we need to think about how to manage them. This is agriculture, right? This is your classic old school IPM, prevention at the base, chemical control at the top, right? That's the last reserve. What is wonderful about agriculture? They harvest it, and then they get all winter to think about what they can change the following year. I am so jealous of this, right? This is if I did a good job or not. They have a bag of beans, they have something they can weigh. They have a very good measure of success, right? It's pretty darn easy to say, I did a good job. In forestry, it's a little bit different, right? There's a time component to this. You don't get all winter to think about, oh, I have a new stock of something to think about. We have this cycle of when we harvest the timber, right? And it's there for a certain amount of time. But, also jealous, there's still a measure of success, right? You have your board feet and the amount of dollars you can assign to those board feet. This is very different than what I deal with. So, I'm going to actually ask a question, and I expect a response. What is my measure of success here? Or, even the better question, how do I determine the threshold here? What threshold do I use for success on the urban landscape?
Also, clean space everywhere.
Okay, yeah. Okay, let me rephrase it. For my clients, for people that call our company and say, this is what I want, what is the level of success? To be beautiful, yeah. Yeah, okay, great.
Happiness.
Hey?
Happiness.
Happiness, yeah, okay, yep. So this is what we call the aesthetic threshold. Every single one of you is going to have a very different aesthetic threshold. So when I come onto your property, one of my first questions is, what is your expectation? If you have a boxwood on your plant or on your property, what is your expectation? No insects, no disease, perfect plants? Or, and I promise you we have a lot of clients that say, I'm only at my Cape Cod house 2 weeks a year with my kids. It has to look perfect. Now, do I want to work with a client like that? No, because we have to spray 400 times. It's not doable, right? Are you okay with a little bit of nibbling? Are you okay with 10% box blight? These are the questions that we have to abide by, and client happiness. Are they going to pay us the bill? I'm a business, right? We're a business. If we don't meet that aesthetic threshold. Very different mind frame. So I'm telling you all of this because this is where I'm coming from. This is the objective. And I love it because I love humans. And it's so interesting to me to work with the biology side, the invasion side, but also the human side of determining what that aesthetic threshold is. So, this is me being extremely damn honest with you all. This is the upside down triangle of what happens in my job. We get an admin, and somebody gives us a call, and they say, I got something feeding on my plant. And they say, oh my God, I got something feeding on my plant, and they're freaking out, right? So what do they say? Do something about it, right? This is the scenario. We show up, and it is an outbreak. They don't call us and say, hey guys, my plant's really good. Can you guys just come look at my plants? They don't call us until there's an outbreak of something, right? So we show up, and we do a course of action, right? And usually that's a chemical action. That's just me being really honest. Hopefully we can say, why did this happen? Sometimes it's an invasive species, and it's because there's no predators or parasitoids or levels of control. A lot of times there's a cultural reason. They are over-irrigating their plants. There's a strimmer that, their gardeners are just destroying the plants. Sometimes there's a drought, right? There's other reasons. Or the trees have been planted too deeply. That's very common. So you have a stressed tree that results in these events. And then hopefully we can do biological control. We have no time to make these decisions. They want that done now, right? That is just the truth of it. So this is me saying, how can we be better? So do we have to fix, sorry. Man, I'm really screwing this up. Nope, there we go. So fixing the immediate problems. Identifying what the problems are, looking at what the inciting factors are. This is the client expectations. This is determining the aesthetic threshold. Yes, maybe we need to do that chemical control, and then looking at all the cultural control things. That's the immediate problems, right? This is the long-term health. So my goal is, yes, I came to your property, we fixed this problem, but what are the long-term issues, and can we form a relationship as a business, right? Yeah, businesses need to make money, but the reason that I'm in this business and the reason that I know a lot of the people that work for us are in this business is for the relationship. I'm very passionate about establishing that relationship with a client to do these long-term health, because I want to see healthy trees in the urban landscape. So the first thing, by far, the foundation of long-term health is soils. Hands down, no questions asked, it's all about the soils. Species selection, right species, in forestry we know this, right? Right tree in the right place, you have to, based on the climate and the soils, put the right species. Mechanical control, there's lots of things we can do for scale insects. We can literally scrub them off. It seriously can be as simple as that, where we have somebody with ropes climb a tree, scrub off the scale insects. Right, we can do that. It takes time, but then going to biological control and chemical control. So this is my reframed IPM with an hourglass. Does this always happen? No. Sometimes we don't get a call back, but it happens a lot. And then we can actually set up monitoring programs where we're looking at the landscape. So this is the second part of the talk. These are the low-hanging fruit of things that I think are worth researching based on what I do and what you all do. And so how we're going to think about this is I'm going to ask a question, go over a little bit of the literature around this question that I think we could do some cool synthetic biology. And then these are the groups of individuals that I think could be part of these projects. So I was trying to be very obedient to Sandy as far as from a synthesis center, what can we do? So the first question is, how does the physiological state of urban trees correspond to the invasion potential of different functional groups of insects and pathogens, right? So on the urban landscape, we know that trees are very stressed. So this is part of Steve Frank. He's an ornamental entomologist at North Carolina State University. His student, Adam Dale, was looking at gloomy scale. This is a native insect that in our native forest doesn't cause issues. But if you go to the southeastern United States, almost every single red maple on the urban landscape is absolutely infested with these plants. And I mean almost 100% infested. And so the question is why is this? Well, if you go into the urban environment, there is this heat island effect, right? So many of these trees are completely surrounded by tarmac. And the heat that is reflected off of this tarmac is really stressing these trees out. And we know that insect populations can explode. Yes, explode because there's a lot of heat for the insect, but also explode because these trees are stressed and they have no carbohydrate reserves to defend themselves. They are barely hanging on. They are very stressed. This is a picture of Battersea Power Station in London. So this is, I think Bear Grylls lives in that condo right there. So very big money, just huge amounts of money. They have planted some beautiful gardens on the top of this roof, right? So I went out there, the landscape manager called us and said, we have a whole bunch of problems, can you please come out? And I said, sure, I'd love to come out with our sales rep. Well, we had huge outbreaks of the Ceciid, the clearwing moths infesting the cherries, pine aphids galore, the black vine weevil, we have spider mite outbreaks, thrips outbreaks, there's spongy moth, cases all over these trees. This is wisteria scale, so there's elm trees completely surrounding this with wisteria scale infestations. Everywhere you look, almost every single plant had some major pest associated with it. If you look around this, all of the heat reflected off of this glass, this is all glass. I mean, it's 5 or 6 degrees Celsius warmer than Reading, which is 20 minutes away. And there's outbreaks galore. So on the urban landscape, we have physiologically stressed trees with outbreaks of insects that wouldn't happen if they weren't in this situation. So how do we measure stress from a physiological standpoint? Really the best ways that we do this is we measure the chlorophyll content of the leaves, and then we measure the chlorophyll fluorescence. So the measure is FE over FM, and it's really a measure of tree vigor. So in some nurseries in the UK, for example, Bartlett's one of the largest nurseries in the UK, we measure how vigorous their trees are for 2 weeks out of every summer to determine the health of the trees. And then when they say, and they put a warranty on those trees to sell to a client, they say, we sell healthy trees, we are confirming that with these measures. So that way they can give it to a client and they know that those trees are less likely to die, assuming the clients water them and plant them correctly, right? So with these units of measure, there is quite a few papers looking at how healthy these trees are on the urban landscape. So I think combining this information that we know urban trees are stressed, and then using these measures of physiological state of trees, I think we can come up with some pretty cool synthetic biology and put some stories together about the invasion potential of urban trees. Does that all make sense? Yep, cool. So moving on. So the next question is, what effect size does landscape type have on the likelihood of pest and disease establishment or growth? So I really think, again, a plant physiologist is important here, as well as some entomologists and plant pathologists. So when I say landscape type, this is what I mean. So this is our research lab in Charlotte, North Carolina. So this is a study I'm actually currently doing right now with crepe myrtles, Lygostromia. So crepe myrtle bark scale is an invasive insect there. So we've planted trees kind of in these situations where we put Lygostromia in the forest, a pseudo-urban area where it's in the middle of the building where there's glass all around it to stress them out, mowed grass or unmowed grass. And then we're measuring things like soil moisture, we're measuring the temperature and the humidity, and then we're looking at all of the natural control that's happening from the natural enemies. And we're using this insect because, based on the work that Sam Ward was mentioned earlier, so him and I did with his student Erica Wright, she found that only one single female ovisac results in establishment in about 85% of the time. So this is an insect that, I mean, the propagal pressure is 1. So from a nursery standpoint, and this is one of the most popular sold nursery trees in the US, especially the South, right? Even if the nursery's doing a really good job spraying their trees and trying to reduce that population, if they miss 1, there's going to be a very large population. And then if you look at the density of these insects, I mean, we're talking hundreds to thousands within a few months resulting from a single ovisac. So it's a pretty cool system to work with. The other thing about this story is the cultural practices done on this. Is this good pruning, Yodi? It's perfect, right? Great pruning. It's terrible, right? But this is the cultural practice. This is what people expect. How often is this done? All the time, right? All the time in the Southeast, people do this. And what they get is these big, beautiful suckers that come up. Now, they will flower, better is what people say, but also what Sam and I and Erica have found is that on these plants, crepe myrtle bark scale prefers these suckers. Why? Those suckers are vigorous growers. The tree is devoting so much energy and turgor pressure to those suckers to get them to grow because they've just been essentially murdered. So they're trying to survive. And that turgor pressure is really great for things like scale insects. So some of these hemipterans will go after these suckering plants, preferably if you didn't do that. So my argument, this is called crepe murder. Don't be a victim. Don't do that, right? The other project that we got going on, so that is Sam. That's also my friend Caleb at the University of Kentucky. So we're kind of doing the same thing that Adam Dale did with red maple. So yes, we know in the urban landscape, populations will explode for gloomy scale, but we want to figure out mechanistically why. So we're doing the same thing where we're planting trees in the forest, in the urban environment, along these gradients, and then measuring all of the attributes, such as the climate and the natural enemies, to really mechanistically understand what is driving that. Is it really just the heat island effect, or are there other factors like enemy escape and whatnot? So yeah, trying to combine all of those things together again, across urban landscape gradients, and then looking at the physiology of the plants. What can we learn from a synthesis standpoint? So next question is, how can we improve the overall health of urban trees to make them more resilient to invasion? This is something I'm really passionate about, right? This is my job. I want to make healthy trees in the urban landscape. Is everybody familiar with this? I mean, to me, this is like one of the best graphs ever made. So this is from Mannion in 1991. And the way that I look at this as my job, these are all things, almost all things, in the predisposing factors that we have control of. I mean, the wooden bark, I have a tattoo of a bark beetle. Like, I like bark beetles, right? I am not crapping on bark beetles here. But they really don't get here till the end. Yes, of course, we have the outbreaks, and there are outbreak species. But in the urban environment, we have control over these things. We have control over soil compaction. We have control over salt. The poor fertility of some of these plants. Yeah, we don't really want them to be super fertile, of course, because that might be an invasive species, but the genetic potential we do. So these are all things that we have some control over. Now, in the urban environment, we only have so much control, right? These urban trees are exposed to so many predisposing factors. So can we change all of these things? No. Maybe with some of the electric cars, we're getting rid of some of the pollution. But yeah, there's so many factors. But to me, one of the biggest ones, we've talked about soil, is soil compaction. So if you think about the new developments that are going up all over the world, from an engineering standpoint, it is legally required by architects and by the states and the government that they compact the soils. So when they build a house, as that ground settles, the house doesn't crack. So at this point, they are rolling over them, and the density, the bulk density of that soil is as hard as a brick. So this is what happens. And this is what we expect, right? So they build this house on that soil and plant those plants and expect them to survive for long periods of time. This is insanity. This is absolutely absurd, and this is crazy, and this is why we will not have really healthy trees in urban areas unless we do something about the soil. The other things are these cultural factors. So I showed this picture of box blight earlier. Why do we see that pattern of box blight? Because of overhead irrigation. This is something that we deal with all the time. Yes, we have this disease. The disease is bad and it can spread rapidly, but it's these cultural conditions, such as people installing overhead irrigation, that cause that. Again, I mentioned strimmer damage and mowing over roots in the urban landscape. So, we actually have situations where, we are killing our own trees. People adore their trees, right? But then they're also getting on their lawnmower, drinking a beer, and driving over the roots and knocking into the tree and creating these entrance wounds for pathogens. And this happens all the time, and we see it on a daily basis. There's so many things we can do. This was a tree that I just came into the other day. It's buried way too deep. This was left on because somebody just forgot about it. If you look down, I'm not even close to the root color yet. Honey fungus, will kill almost every tree in the UK. And we see plants like this all the time not establishing because they're planted way too deeply and honey fungus invades that really wet, moist root collar. We just cannot have healthy trees if we continue doing this. This is what we want to see, right? If you think about what we should have as a root collar on the urban landscape, just think about the forests. Think about what you actually want to see. And we very rarely see that on the urban landscape. And in order to create this healthy urban landscape, it's not going to happen unless we change the way that we do things. And then the other thing is these predisposing biotic factors, right? So, I mean, this is kind of, further down the line in the Mannian spiral decline. But again, the box example, there's between all the cultural issues associated with it and all the predisposing biotic factors, there's just so many things wrong with box. So the question becomes, should we continue planting box, right? You say no. Anybody that has a Victorian or Georgian home in England would say yes. It's a very important part of my garden. So there's the cultural aspect of it, that people value it deeply. Also in America, it's resistant to deer browse. And from Pennsylvania's standpoint, if we planted a high deer browse plant on Sandy's yard in Pennsylvania when he was there, that plant would be destroyed. Right, Sandy? Yeah. So I think maybe down to my last one. But how pest or disease susceptible are climate resilient plants that are slated to be planted on the urban landscape? So climate change, we talk a lot about it. What plants are going to be planted in the urban landscape in the future? And we need to think about the invasion potential of these plants. So Kevin Martin, he's with Kew Gardens, so he's doing a PhD right now of what plants are going to be planted in England and the rest of the EU as we go into future climates, what native species are not going to survive, and what non-native plants are not going to be invasive that we should be using in the urban landscape. A lot of this work's already being done. And we also have lots of literature out there. Mediterranean oaks are outperforming native oaks in the UK. I mean, that's a scary thought. And so people are going to take this information and start to think about what plants should we put in the urban landscape. I mean, hopefully we can still plant some of the native oaks, but people are going to consider planting Mediterranean oaks in the UK. This is being considered right now. Taipuna taipu, so this is rosewood from Brazil. We know this is a drought-tolerant species that can support cities, right? Is this something that we should do? I'm not going to answer yes or no, but these are the kind of questions that are being asked right now. And then thankfully, there's lots of people in this room working on Sentinel projects. So these Sentinel projects are extremely important from my point of view in the urban landscape going forward as these drought-resistant, drought-tolerant, flood-resistant, flood-tolerant plants are being put in the urban landscape. This is where, to me, this data becomes critical. And I'm very excited for that. And I'm going to stop here. This will be my last slide. So we still have a Mr. Bartlett. We're a third-generation company owned. He's 87 years old, so he's buying up land and trying to leave a legacy behind. So he just bought 50 acres of land in Reading, UK, and we're building a $2.5 million research lab here, and we are going to be planting a climate change resilient arboretum. So right now, I mean literally right now, this is a picture from like a week ago, we will be, over the next 10 years, planting out this arboretum to look at what species will survive in the UK. So he looks at that as critical work, and I'm really excited to be part of that. So I'll stop there, and thank you so much for your time and attention.